Okay, this is day 5 of Unit 8. Today we started with a ticket quiz, so you'll need to make that up if you were absent. And then we did this warm-up, pause the video, try the warm-up, play to check your answers. So the question is, how many terms are in this series? Well, in order for me to answer that, I need to decide what kind of series it is. So I can see 3, 6, 12, 24. That's a geometric series. So I'm going to use the explicit formula, like we always have used the explicit formula to help us figure out the number of terms. So I'm using the explicit geometric formula, which remember is a sub n a sub n equals a sub 1 times r raised to the n minus 1 power. So I'm substituting in 3072 and 3 in for a sub 1, and looks like 2 is the r to the n minus 1 power. So I'm going to divide both sides by 3 as I'm trying to solve for n. So when I do that, 3072 divided by 3 gives me 1024 equals 2 to the n minus 1. Now, we have two options for solving here. Because 1024 is a power of, or can be rewritten with a base of 2, I can just do that. Or if you didn't realize that or forgot, you could take the log of both sides. So either rewrite 1024 as 2 to the 10th is equal to 2 to the n minus 1, and then set 10 equal to n minus 1. So n is 11. Or take the log of both sides. So up here, this step here, so log of 1024 is equal to the log of 2 to the n minus 1, which means I can use my power property and bring the n minus 1 out front. N minus 1 times the log of 2 is equal to the log of 1024. And then we would divide both sides by the log of 2 and add 1. So n is going to be equal to the log of 1024 divided by the log of 2, and then plus 1, and that is 11. Okay, so there are 11 terms in this series. All right, so next, we're supposed to find the sum of this series. Well, notice that is the same series that we just found the number of terms for. So normally, if you're finding the sum, you are going to have to figure out how many terms there are. So we've already done that. So step 1 is to figure out how many terms, and there are 11 terms. That's step 1. Okay, again, we've already done that, so look back in the warm-up if you forget what we did, but we've already figured out that there are 11 terms. So that's step 1. Okay, secondly, we're going to figure out what kind of series this is so that we use the appropriate formula. And remember, again, we've kind of already done that. We decided that in order to figure out the number of terms, we had to decide what kind of series it is, and we decided it's geometric. So I see that it's geometric series, and I see that it's finite. It has an ending value or ending term rather than plus dot dot dot. So I know it's not infinite. So now what I need is the finite geometric sum formula, and I haven't taught you that yet. So can't just use the finite arithmetic formula because this series is not arithmetic, it's geometric. So we won't use that formula, we'll use the geometric one. So the formula for a finite geometric sum starts off just like the finite arithmetic. It starts off S sub n, but from there it's not really similar. So we have a sub 1 times the quantity 1 minus r raised to the n all over 1 minus r. Unfortunately, I don't have a nice story to help you remember this one like I did for Gauss and the sum, finite arithmetic sum. So you are just going to have to memorize that or learn it as you're using it often enough. Hopefully you'll get it memorized. So we're going to use that formula now to figure out this sum. So I know that it's S sub n being the number of terms. So again, I would have to figure that out normally, but we've already done that. So S sub 11 is equal to, the first term is 3 times 1 minus r, we said earlier, is 2. And that's raised to the nth power, which is 11. And I'm going to put that over 1 minus 2. So I do want you to simplify by hand, not type that whole thing in the calculator. So 3 times 1 minus 2 is -1 in the denominator. And I'm going to follow order of operations. So 2 to the 11th has to come first, which is 2048. And then I'm going to simplify that. So 1 minus 2048 gives me -2047. And I'm going to multiply that by 3 and then divide by -1, which gives me, let's see here, -6,141 divided by -1, which gives me +6,141. So S sub 11 is 6,141. Okay. That takes care of that. So now let's try this one. So go ahead and get that one in your notes. So again, the first thing we have to do is to figure out what kind of series this is and how many terms it has. So by looking, based on what we talked about yesterday and the last couple of days, you should be able to recognize that this is a geometric series, and you should realize that because the equation is exponential. We have a variable exponent. So exponential equations come from geometric series. So I know it's geometric, and I know it's finite because I don't see an infinity at the top here of the sigma. I see a number. So finite and geometric means that same formula again that we just used. So S sub n, well, I need a number of terms. So remember, we take 10 upper index minus the lower index, which is 9, and then we add 1 always, which gives us 10 terms. So we're looking for the sum of the 10 terms. That's going to be equal to a sub 1, which is the first term. Now, you don't want to look here and just assume that that first term is 5. It might be, but it actually could vary depending on the exponents and the lower index and how they're set up. So we don't want to assume that that is the first term. So we're going to actually find the first term just to confirm. If we suspect it might be 5, we're going to confirm that. So to do that, to get the first term, remember, we're going to substitute the lower index in for the exponent, or into the equation. So we have 5 times -2 raised to the 1 minus 1 power. Well, that's 5 times -2 raised to the 0. Anything to the 0 power is 1, and 5 times 1 is 5. So now we've confirmed that 5 is the first term. And like I said, it's not always going to be that number right in the front, but in this particular case it was. So we have first term times, remember, it's going to be 1 minus r to the nth and 1 minus r. So I'll write the 1 minuses a while. And then I need the r value, which, again, I'm not going to assume. I'm going to figure out what the r value is. So in order to get the r value, I need to look at the second term to see what we multiplied the first term by to get the second term. So to get the second term, I'm putting in the next highest integer, which is 2. So 5 times -2 to the 2 minus 1 gives me 5 times -2 to the 1. -2 to the 1 is -2. And 5 times -2 is -10. So to get from 5 to -10, I know I multiply by -2. So r is -2. So back to my formula here, I have 5 times 1 minus -2 is raised to the 10th power, and that's over 1 minus -2. So in the denominator, I have 1 minus -2. I'm allowed to do keep it, change it, change it. I'm allowed to do minus a negative is plus a positive. So 1 plus 2, that's 3. In the numerator, though, it's 5 times 1 minus -2 is being raised to the 10th. So order of operations, -2 to the 10th goes first, and then I'm subtracting that from 1. So I can't change that to plus positive. So you have to be careful with that. So I want to do -2 to the 10th first. So I'm doing 5 times 1 minus, I'm doing negative 2 to the 10th, which is 1024. And then I'm subtracting from 1. So I have 5 times negative 1023. And let's see what I get when I simplify that. 5 times negative 1023 is negative 5115, and I'm dividing that by 3, which gives me negative 1705 is S sub 10. Okay. So next, let's simplify here. Once again, we have to figure out what kind of series this is. I see an exponential equation, which means I know it's geometric. I'm going to figure out number of terms. So 25 minus 4 is 21, plus 1 is 22. So I know there are 22 terms. I'm using the geometric finite formula, which again, we just used twice now. So S sub 22 is equal to a sub 1, which we're going to figure out, times 1 minus r to the nth over 1 minus r. So let's take a moment and figure out what the first term is so that we can substitute that in front of the 1 minus r to the nth. Okay, so let's substitute in the lower index here in for n into the equation so that we can figure out what the first term is. Now, be careful. Our formula, remember, says S sub n equals a sub 1 times 1 minus r to the nth over 1 minus r. Sometimes students will think, well, this says a sub 1 and my subscript's a 1, so aren't I supposed to put 1 in here for n? Just be careful. This is not saying that you should put 1 in for n. What this is representing, a sub 1, is representing the first term. It just so happens that this particular one, I don't get the first term by putting 1 in for n. I get the first term by substituting the lower index in for n. And in this particular problem, the lower index is not a 1. So I have to put a 4 in. So it seems a little weird to some students that we're putting a 1, that we're not putting a 1 in here to get the first term. We're putting the lower index in to get the first term. So just be careful with that. So anyway, if I put in a 4 for n, I'm getting 1/3 to the 4 minus 1, which is 1/3 to the third. And 1/3 to the third, I can do that in my head. 1 cubed is 1 and 3 cubed is 27. So 1/27 is a sub 1. Okay, but again, we got that by using n being 4. So 1/27 goes in for a sub 1, which is in the front of the equation or formula. So 1/27 goes there. Now, my r, I think it might be 1/3, but I want to just confirm that. So let's get the second term of the series and see if it indeed it is 1/3. So the second term, I'm going to put the next highest integer, which is 5. So 1/3 to the 5 minus 1 is going to be 1/3 to the 4th, and 1/3 to the 4th is 1 over 81. 1 to the 4th and 3 to the 4th is 81. So 1/27 was the first term, and then 1/81 was the second term. So now the question is, how do I get from 1/27 to 1/81? 1 over 81, I multiply by 1/3. So the r value is 1/3. Okay, so now I know that for certain, so I'm going to go ahead and put that into my equation here, or my formula for r. So 1 minus 1/3, and that's raised to the, remember, 22nd power. And then we're going to put that over top of 1 minus a minus sign minus r, and r is 1/3. So I have s sub 22 is equal to 1/27 times 1 minus 1/3. I know it's 2/3. And here you're going to type in into your calculator 1/3 to the 22nd. When you do that, hopefully you're going to see it's probably going to be a really, really small number in scientific notation in the calculator. And then when you do 1 minus that really, really small number, you're going to see that the calculator just rounds it to 1, which means that this 1/3 to the 22nd is so small that the calculator is just saying it's 0. It's just rounding it to 0. So when that happens, that's fine. Just let the calculator round it to 0, which means 1 minus 0 is 1, and 1 times 1/27 is 1/27, and 2/3 is in the denominator. We know how to divide fractions without a calculator. So 1/27 times 3 halves simplify the diagonal, so that's 1 and 9. So that gives me 1/18. So the sum of these 22 terms is 1/18. Okay. All right, your assignment for Monday is worksheet 3, those particular problems, and worksheet 4, those problems. Do those for Monday. Again, try and stay on top of your assignments. Don't fall behind. We have a couple quizzes coming up anytime next week. I'm not announcing them specific dates, but they could be anytime next week. And then next week on Friday is your test on this unit, Unit 8.